You are probably quite familiar with Python, but maybe web scraping is still something new. Or maybe those pesky URL libs are becoming a hassle to deal with. Well, in that case, you don't have to dig deep to see that requests is the premier Python library for sending HTTP requests. In this video, I will explain the basics and some advanced uses of the request library, including sending GET and POST requests, reading responses, using request headers, dealing with authentication, and more. Let's get started. Requests is a third-party alternative to the standard URL lib modules. URL libs 1, 2, and 3 can be confusing and often need to be used together. Thankfully, requests greatly simplifies the process of sending HTTP requests. Standard Python HTTP libraries are difficult to use and often require significantly more statements to do the same thing. Compared to requests, URL lib 3 can take twice the amount of code lines. Requests make the code easier to understand and debug, even for an untrained eye. The intuitive API makes it easy to send HTTP requests while supporting a variety of HTTP methods, including GET, PUT, delete, head, options, and patch. Requests isn't a part of the Python standard library. It needs to be downloaded and installed through a terminal. I recommend using the terminal provided in the coding environment, for example PyCharm, as it will ensure issue-free installation. Before using, import the library. Out of all the possible HTTP requests, GET is the most commonly used. GET request is an attempt to acquire data from a specified source, usually a website. To send a GET request, invoke requests GET and add a destination URL. The most common outcome after sending request is a code 200 message. The 200 response indicates that the request was successful. 400 bad request, usually malformed request syntax or invalid request message framing. 401 unauthorized, the request requires supplying valid credentials. 403 forbidden, the server understood the request, but it will not fulfill it. In cases where credentials were provided, 403 would mean that the account in question does not have sufficient permissions to view the content. The good old, or rather bad in this case, 404 not found, the server found no content matching the request URI. Sometimes 404 is used to mask 403 responses when the server doesn't want to reveal reasons for refusing the request. 429 exceeded the rate limit imposed by the server. Essentially, the server is receiving too many requests from the client within a specific time frame and has temporarily blocked further requests. An example of how to handle a 429 error might look like this. Sending a GET request and creating logic that would delay the next request in case of a 429 response from the server. Status codes can also be used by creating an object and using the print object status codes function. Tell me more about some unusual error codes that you get in the comments below, and consider subscribing if you would like us to cover them in an upcoming video. GET requests can be sent with specific parameters. Parameters follow the same logic as if you were to construct a URL by hand. Each parameter is sent after a question mark is added to the original URL, and pairs are split by the ampersand sign. Their URL would now be formed like this. Yet, while useful, status codes by themselves do not reveal much about the acquired content. So far, you can only know if the acquisition was successful or not, and if not, for what reason. To view the request's response object sent by a GET request, you should create a variable. For the sake of simplicity, let's name it response. Do note that in requests, The timeout value is set to none by default, which means that if you do not receive a response, the application will hang indefinitely. You can now access the status code without using the console. To do so, you will need to print out a specific section, status code. So far, the output will be identical to the one received before, which is 200. Note that the status codes have Boolean values assigned to them. From 200 to 400 is true, 400 and above is false. Using response codes as Boolean values can be useful for checking whether the response was successful before continuing to perform other actions. To read the content of the response, you need to access the text part by using response text. Printing the output will provide the entire response into the Python debugger window. Requests automatically attempts to make an educated guess about the encoding based on the HTTP header. So providing a value is unnecessary. In rare cases, changing the encoding may be needed, and it can be done by specifying a value to response encoding. The specified value will then be used whenever you make a call. Responses can also be decoded to the JSON format. HTTP bin doesn't send a request that can be decoded into JSON. Attempting to do so will raise an exception. For explanatory purposes, let's use GitHub's API. Using the JSON function returns a dictionary object that can be accessed and searched. Response headers are another important part of the request. While they do not contain any content of the original message, headers hold many important details of the response, such as information about the server, the date, encoding, and more. Every detail can be acquired from the initial response by making a call, print response headers. As with the JSON call, headers create a dictionary type object which can then be accessed. Adding parameters to the call will list out a part of the response. The function will now print the data stored in the response header. Values are considered case-insensitive, and requests will output the same result regardless of capitalization. You can also send custom headers. Dictionary-type objects are used yet again, although this time they have to be created. Headers are passed in an identical manner to parameters. To check whether your request header has been sent successfully, you will need to make the call response request headers. Running this code should output the request header in the debugger window with the user agent stated as myagent101. As a general rule, sending most common user agents is recommended, as otherwise, some websites could return a 403 forbidden response. Check the most common user agents for web scraping following a link in the video description below. Custom HTTP headers are usually used for troubleshooting or informational purposes. User agents are often utilized in web scraping projects to change the perceived source of incoming requests. Post request is the second most used HTTP method. Post requests are used to create a resource on a server with a specified data. Sending a post request is almost as simple as sending a GET request. All HTTP methods except head return a response body that can be read. Responses to post requests can be read in the same manner as GET or any other method. Responses correlate to the type of requests made. For example, a post request response contains information regarding data sent to the server. In most cases, specifying the data in the post requests might not be enough. The request library accepts arguments from dictionary objects, which can be utilized to send more advanced data. The request would send the payload object to the destination server. At times, sending JSON post requests can be necessary. Requests have an added feature that automatically converts the post request data into JSON. Alternatively, the JSON library might be used to convert dictionaries into JSON objects. A new import will be required to change the object type. Note that the JSON argument is overridden if either data or files is used. Requests will only accept one of the three in a single post request. Post and GET are the two most common HTTP methods in use. For example, web scraping API users utilize only these two HTTP methods to send requests, post, and retrieve data, GET. Yet there are many more ways to interact with servers over the HTTP protocol. PUT replaces all the current representations of the target resource with the submitted content. Although PUT and POST requests may look similar, PUT requests are idempotent. This means that multiple requests will have the same result. If you make multiple PUT requests, each will override the same resource, whereas a POST request will create a new resource. Sending a PUT request is the same as sending a POST request, but using the PUT method. Delete removes all the existing representations of the target resource given by URL. The delete method sends a request to a specified URL and is made to delete a specified resource. Sending a delete request is the same as sending any other HTTP request. Let's make a sample delete request that deletes the delete resource. You can print the status code to check the received response. Head, just like GET, but also transfers the status and header section. The head method requests data from the web server. It only returns the information about the web server and not the content itself. This makes it faster than a GET request. Developers can include a custom header defined by their application to provide additional information or authentication credentials to the server. Options states the communication options for the target resource. The options method retrieves a response object containing all the data and properties such as response content, headers, encoding, cookies, and more. Patch applies modifications to a specified resource. The patch request must only include the changes to the resource, not the entire resource. This is similar to PUT, but the body contains instructions describing how to modify a resource currently on the server to produce a new version using the patch method. All of these HTTP methods are rarely used outside server administration, web development, and debugging. An average internet user will not have permission to perform actions such as delete or PUT. Other HTTP methods are most useful for testing websites and are often outside the field of interest of the average internet user. Of course, the most widely used method is GET, which allows developers to pull data from an API using the request package. Let's use the requests GET method to send an HTTP GET request to http://bin.org. Now you can use this response object and methods such as status code, content, text, and JSON to get more information. An authenticated request is a type of request where the sender must provide some form of authentication to access the requested resource from a session instance. The authentication mechanism can vary, but usually involves sending some token or credentials along with the request. To send data via authenticated requests, you need to obtain the necessary authentication credentials. This can vary depending on the API or servers you are working with, but some common authentication methods include API keys, open authorization tokens, and basic authentication. Once you have the authentication credentials, you can use the request library to send a request with the appropriate authentication headers. Here is an example of how to send a POST request with a JSON payload and basic authentication. You can manually add query strings to the URL to change the payload destination. First, define the URL you want to send the request to and the payload you want to send in JSON format. Also, specify the authentication credentials using the basic authentication method, providing a username and password. Set the content type header to specify that you are sending a JSON payload. Then, use the request's post method to send the request with the authentication headers and JSON payload. If the request is successful, such as the one with the code 200, print a success message. Otherwise, print an error message with the response text. Retrieving data via authenticated requests is similar to sending data, but instead of sending a payload, you are requesting data from the server. You must also provide the appropriate authentication credentials to access the requested resource. Here is an example of retrieving data via authenticated requests using the GET method and an API key. Define the URL you want to retrieve data from and provide the API key using the authorization header with the bearer token type. Stay tuned for more about the bearer token in a little bit. Then use the request's GET method to send the request with the appropriate authentication headers. If the request is successful, print the retrieved data. Otherwise, print an error message with the response text. Securing communication across multiple systems is critical to protect data confidentiality and integrity. Using SSL TLS certificates that allow encrypted connection between systems is a technique to assure safe communication. SSL verification is a process that checks the identity of the server you are connecting to and assures the validity of the SSL TLS certificate presented by the server. SSL verification is essential for preventing man-in-the-middle attacks, where an attacker intercepts communication between the two parties and modifies the data being delivered. To ensure secure communication, the requests library performs SSL verification by default. But in some circumstances, such as when working with self-signed certificates or testing on a local server, you may need to disable SSL verification. To do so, set the verify argument to false to deactivate SSL verification in the request library. Here's how to send a GET request to a server without using SSL. If the server's SSL TLS certificate is invalid, the library will throw a certificate error exception. But sometimes, you need to supply your SSL TLS certificate or utilize a bespoke CA certificate authority package. To enable SSL verification with a custom CA bundle, use the verify argument to give the path of the CA bundle file. Here's an example of using a custom CA bundle to send a GET request to a server with SSL verification enabled. Bearer tokens are often used in APIs for authentication and authorization. To use a bearer token with requests, you can include it as a header in HTTP requests. Here is how to use a bearer token to send a GET request to an API. Define the URL for the API endpoint from which you wish to get data and give the bearer token as a header in the authorization field of the requests using the headers argument. Using the get method, if the request is successful, a 200 status code is given. Use the response JSON function to convert the JSON data returned by the API into a Python object. In that case, print an error message and the response content. As you can see, requests is way easier to use than URL-lib, and you can create simple applications from the get-go. Check the videos linked in the description below if you would like to learn more about the use of Python in public data extraction. Let me know in the comments if you would like to hear more specifics about the request library or Python in general. Thanks for watching, and I hope to see you next time.